Good afternoon. My name is Mykola, and I want to present to you a report on the topic nCode GlyphWorks software used for test data processing. It contains from introduction, test data obtaining and correcting, means of obtaining test data correction, conclusion, and acknowledgements. Measurement or experimental determination of the values of physical quantities by special hardware is the basic way to obtain some information about the environment and the process occurring in it. The results of any measurements, despite the accuracy of the procedure, are likely to have some errors. It may be caused by the impact of different external factors on the measurement process result in an offset on the sensor output. This effect may cause some errors in the results, so a researcher must be able to apply some methods of test data correction. Nowadays, there is a great number of hardware and software for signals obtaining, segmentation, statistical analysis, processing, and modeling. Among the whole range of various software for the work with experimental data, the software nCode made by company HBM Prensia. nCode GlyphWorks software has a convenient object-oriented graphical interface and is optimized for the complex work with large volumes of multi-channel data. nCode GlyphWorks software has a module system which enables us to create the required feature set either by means of large embedded libraries or by the use of language Python. The goal of the work is digital processing by nCode GlyphWorks software tools of the test data obtained by while studying the stress-strain state of a wide spray field sprayer boom on a purpose-designed and made test bed to study the dynamic loading of mobile agricultural machinery. Test data of stress-strain state of a sprayer boom parts have been obtained by tensometric method, with incoming signals recorded by the developed universal measuring system fitted with analog digital converter with the total number of measuring channels 8. The preset operation parameters of the universal measuring system include gain ratio, cutoff frequency of low frequency, a mode of measurement, connection diagram of the channel, power supply voltage of sensors, values of zero shift, a period of discretization, and a kind of separating characters between the recorded data. These parameters are prescribed before the start of the measurements by means of mod.dat file information. For test data preliminary processing has been developed a special software, providing the data sorting of the obtained array to certain channels and reducing the digital codes of each channel to the real physical quantities with dimensional units, for example, deformation or stress. Due to the test data array processing by the developed program, we have obtained the data from the first 4 separate tensometric channels of the universal measuring system. To next process this data, we have used nCode GlyphWorks software. The general view of interface nCode GlyphWorks is shown on this slide. These are main windows of the GlyphWorks interface. First, Analysis Workspace, where the process is created. Second, Available data, data that can be analyzed. Third, Diagnostics, list of process, error messages, etc. Fourth, Glyph palette, glyphs available for processing. In GlyphWorks, a process is defined as a combination of glyphs that define a data flow. A process typically starts with an input glyph to define the data to be processed. Additional glyphs define subsequent steps in the process for calculation display or written output. To implement the procedure of test data correction has been developed a detailed design containing the following structure elements, glyphs: Excel input, multi-column to time series, running statistics, arithmetic, time series output, and XY display. The parameters of each glyph are set in its properties. For example, here settings of the multi-column to time series glyph properties. The following parameters should be specified in the properties of this glyph. Method resample, sample rate 500, interpolation linear. This slide shows the incoming data that the XY display glyph represents. The results of statistical processing of test data from channel number 3 by their average value are shown on this slide. The upper curve shows the data incoming array from channel number 3, and the lower one represents their average values. A method of test data correction consists in the separation of average values from the data array so that to reduce the curves to the normal zero level. The results of test data correction by described procedure are shown on this slide. To check the adequacy of the obtained results, we have compared them with the results of incoming data processing by means of the standard procedure, that's the use of a filter of high frequency, which enables to isolate the low frequency signals from the data array. In nCode GlyphWorks, this possibility can be implemented by frequency filter based on the tool Butterworth filter glyph. In this graphic, two curves of first channel are displayed obtained due to incoming data array processing by two different methods, by average value subtraction of the initial data array and using the filter of high frequencies. To make the comparison more convenient, the curves have been superimposed. As we can see on this figure, the results of test data correction by two methods intercommunicate well. The both methods, from the engineering point of view, correctly describe the conversion procedure of the results obtained by the method of signals digital capture from the tensor sensors installed on the real structure. In this corrected data, the drift of average values on the process has already taken into account, enabling to determine the real number of cycles of the structure loading. And so, conclusion. The results of any experimental research dealing with data collecting and processing are likely to have some errors. The analysis of obtained results and errors of measurement is an essential part of any scientific experiment, so a researcher must be able to apply some methods of test data correction. At present, there is a great number of software for signals obtaining, segmentation, statistical analysis and processing. The software nCode, which was designed to work with large volumes of test data, makes possible to carry out processing of experimental signals, both by standard methods and by the developed alternative techniques of data processing. In the paper under discussion, the drift of experimental data has been corrected so that to reduce the test data curves to the nominal zero level. Two approaches have been applied to test data correction to remove the drift effect, namely the use of high-frequency filter and the removal of the data array average values. The results of test data correction by two methods have intercommunicated very well. Both methods, from the engineering point of view, correctly describe the conversion procedure of the results obtained by the method of signals digital capture from the tensor sensors installed on the real structure. The obtained results can be used in carrying further of research of the structure durability. Acknowledgements. I am very grateful to the company HBM Prencia and the team nCode for the possibility to use their software and for the information support. My special thanks to Lukasz Piniak, account manager Prencia. I highly appreciate the assistance of the managers of the company Bohuslav Agriculture Machinery, Petro Gavrilenko and Mykola Gavrilenko, in their cooperation with the Department of Technical Mechanics and Agricultural Machines of Ternobyl Ivan Pulin National Technical University during the experimental studies of the dynamic loading of wide spray field sprayer boom. Thank you for attention.